Dear children, here in this program, I'm going to demonstrate one more logic for checking a prime number, but with a different manner. Here in this, I'm going to just print all the prime numbers between 1 to 1000 with the help of this code. Here in the main method, you see that I have created the object of the class. Here I have started a loop from 1 to 1000. And here with the help of this function call statement I am calling the above function within this main method, and whenever the function is going to return true, I'm going to just print the value of I. Now here within this function, what I have done, this is very important. In this function, what I have done, any positive, any integer which is less than 2, I have ignored. It will not be a prime number. So any number if any number which is less than 2, in that case the function is going to return false. And in positive integers, only 2 is the even number which is a prime number. So in that case I'm checking if any number which I have entered is 2, then immediately return true. And rest of the even numbers will not be a prime number. So if the number is not less than 2, and if it is not 2, and if it is an even number, then the function is going to return true or false. Now for the rest of the number, it simply means that I have ignored less than 2 integers, I have ignored even numbers other than 2. It means only odd numbers are left. So here with the help of this code, I am checking if any odd number from 3 till that number, if it is the multiple of that, number, in that case the number will not be a prime number. For example, here suppose I have entered 10. So in case of 10, I have the loop, I have ignored. Suppose the number is less than 10, then here in this case the number is not less than 2, so it will come here, the number is not 2, this is also false. But here you see that since the number is even, it is not less than 2, it is not 2, it is 10, which is an even number. That's why in case of 10 the function is going to return false. We need not to count the factors in this case. Suppose the number is 9, then what will happen? This 9 is not less than 2, this 9 is not 2, this 9 is not even, then what will happen? This loop will start. The loop has started from 3, and here we are checking if 3 into 3, which is 9, is less than or equals to 9. The condition is true, but since 9 is divisible by 3, 3 is the multiple of 9, it means this 9 is not a prime number. Immediately we are going to return false. No need to check further, no need to count the factors here. In another example, suppose 11. 11 is a prime number. See how? In case of 11, this function will return true. How? We have got the number 11. This 11 is not less than 2, so this false will not execute. This 11 is not 2, so this true will not execute. This 11 is not an even number, so this part also will not execute. Here what will happen? For this 11, this loop will start from 3. Here it is what? Here it is 9, and this 9 is not less than or equals to 11, so loop will go 9 is less than or equals to 11, it is less than 9 is less than 11, so loop will go, but 11 is not divisible by 3. I is 3, this 11, I was 3, and here I into I is 9. So 11 mod 3 is not divisible. This false will not execute. I becomes 5, And then what is checking, what we are checking here, we are checking if 25 is less than or equal to 11. No, it is not true. The loop will terminate, then the control will come here returning true. So in this case 11 is a prime number. On the other hand, suppose I have considered another integer which is 29, suppose. So see what will happen. In case of 29, what will happen, this loop will start from 3. So here at present the value of I is 3, and what is happening here, it is 9. So 29, it is 29. 29 mod 3 is not divisible, so this part will not get executed. So what I plus 2 will happen, so it becomes 5. Now in case of 5, what is 9, it becomes 25. So 25 is less than or equals to 29. This is again true. Control comes here within this block. What will happen, 29 mod 25, so 29 mod 5 is not divisible, so false will not execute. What will happen, this I becomes a 6. This I becomes a 6. What will happen here, it becomes 36, and this 36 is less than or equals to 29. This loop will terminate because this condition is false. So when this condition is false, the loop will terminate, control will come here returning true. That's why 29 is also a prime number. Let us see that. Here in this case, you will see the loop goes from 1 to 1000, 1 to 1000, and returning all the prime numbers on the screen. So this is another code with the help of which we need not to count the factors, and this code goes less number of times than the previous code of checking the prime number with the help of counting the factors. Because in case of, if in previous case, if the value was 29, in that case the loop was going from 1 to 29, counting the factors of all possible values of I. And then, but in this case what is happening, we have checked only for the values which is 2, 3, and then 5, and when the value becomes 6, the loop terminates. It means only 4 iterations are there in this particular case. In the previous example of prime number, in the previous case there were 29 iterations within the loop. That's why this code is much more efficient. I hope you have enjoyed this video. Thanks for watching.